Usually when we think about hospital technology, there's this expectation of absolute unforgiving precision.
Oh, absolutely. It has to be. Or at least, that's the expectation.
Right. We treat it like aerospace engineering.
Yeah.
I mean, you go in for an MRI, the machine hums, and out pops a perfect high-resolution slice of your anatomy.
Yeah, when lives are literally on the line, the tolerance for error drops to zero. You just expect it to work.
Exactly. We assume the software running that machine is just as immaculate. But then you look behind the curtain at how some of that medical software actually gets built. And, well, suddenly the illusion of perfection just vanishes.
It really does. It's a completely different reality.
Yeah, if you peel back the casing, you often find a development landscape that is incredibly chaotic. We're talking about critical systems held together by, digital duct tape.
Which is the absolute definition of technical debt. It's
Yeah.
just people bolting new features onto old code without any central plan, just praying the next update doesn't bring the whole network down.
It's terrifying when you really think about it. But anyway, welcome to the Deep Dive. Today we are opening up an excerpt from a really thought-provoking book called Smart Innovation by Professor Mikel Piano.
It's a fascinating read.
It really is. The overarching focus is on artificial intelligence and sustainable innovation. But our mission today isn't to get lost in abstract theories about the future of robots,
No, we want to keep it grounded.
Exactly. We are looking at a specific, fascinating contrast presented in the text. We're going to explore how a highly successful, meticulously planned hospital tech project from the 1990s, followed immediately by a disastrous, improvised spin-off, serves as, the ultimate warning label for how you and I are using AI today.
It serves as a perfect historical case study. I mean, it strips away all the modern hype surrounding generative AI and forces us to look at the human methodology behind the tools.
Because the tools change, right?
Exactly. The tools change, but human shortcuts rarely do.
It's so true.
Yeah.
So to understand the current chaotic landscape of large language models, or LLMs, we actually have to go back to an Italian radiology department in the 1990s. Okay, let's unpack this.
Right. So the author takes us back to a major collaboration he led with IBM.
Okay.
They were tasked with developing the very first voice reporting system, what they called refertazione vocale, for the radiology department at the Casa Sollievo della Sofferenza.
Which is the San Pio Hospital.
Yes, San Pio Hospital. And we have to pause and appreciate the context of that for a second.
Oh, absolutely. Voice reporting in the 90s, that is bleeding edge technology for the time.
It really was. We aren't talking about asking your phone to set a timer here.
Right.
This meant translating complex medical dictation into digital text over 1990s network infrastructure.
Which was not exactly fiber optic speeds back then.
Not at all. The friction involved in doing that analog to digital conversion back then was immense. I mean, you had to manage heavy audio files, route them to the correct patient records, and ensure the local network didn't just completely bottleneck.
Sounds like a nightmare to build.
It was incredibly complex. But the crucial takeaway the author highlights is that this massive project was a resounding success.
Wow.
Yeah, but he makes it very clear that this wasn't due to luck or even just having IBM's deep pockets. It succeeded because of rigorous foundational planning.
And he is incredibly adamant about this in the book, isn't he?
Very much so.
He states that an IT project is absolutely no different from a physical building construction project or a heavy automation project.
Exactly. You cannot underestimate the steps involved. It requires meticulous preventative design before a single line of code is written.
Right. The logic there is that you have to treat software architecture with the exact same reverence you treat physical architecture.
Because the cost of failure, especially in a hospital setting, is just too high to wing it.
You can't just try things out on live patients.
No, you can't. So they spent months mapping out user workflows, network constraints, and database structures.
I love this framing because it makes the invisible tangible. Think about it. You wouldn't just show up to an empty dirt lot with a pile of bricks, a couple of trowels, and start pouring concrete without a blueprint.
Definitely not.
You wouldn't say, well, let's just build a load-bearing wall here and see how it feels when it rains.
Right. That would be insane.
But isn't it wildly tempting in software to just sit down and start typing code simply because the materials are invisible?
Oh, it's the perpetual trap of digital creation. When the materials are just pixels and code, the friction to start building is practically zero.
Yeah, you just open a window and go.
Exactly. You don't have to wait for cement to dry or permits to clear. So Developers often jump straight into execution, completely bypassing the architectural blueprint phase.
Right.
But at San Pio Hospital, they resisted that temptation. They planned the software like they were planning a new surgical wing.
Which is why it actually stood the test of time and worked. And, think about the last time you rushed into a project at work without mapping out the architecture first.
Oh, we've all been there.
Right. Maybe you started building a massive spreadsheet or throwing together a presentation without outlining the core message. How much time did you end up spending untangling your own mess later because you skipped that initial planning phase?
And that untangling phase is exactly where the story takes a sharp turn.
Oh, here we go.
So the initial voice reporting project was so robust and successful that it naturally created a new demand. The hospital needed to scale it.
Makes sense. It worked, so they wanted more of it.
Right. Professor Piano realized they needed a downsizing of the massive project. Essentially a simplified, scaled-down version specifically tailored for the smaller radiology laboratories.
Okay, so they have the blueprint of a skyscraper, and they just need to build a 2-story clinic.
Exactly. And to handle this, the author entrusted the task to a group of recent computer science graduates.
Which, logically, you would look at that setup and expect the smaller version to be vastly easier to execute.
You would think so. I mean, the heavy lifting had already been done by the IBM team. The underlying concepts were proven.
Yet the result was a total, unmitigated disaster.
Total failure.
The author is beautifully blunt about this. The project completely fell apart, and the reason he gives is so revealing. He says the young graduates abandoned the methodology.
Yes. They relied on improvisation rather than elementary project design basics.
What's fascinating here is how perfectly this illustrates the danger of skipping the blueprint phase. They made a fatal assumption that plagues the tech industry to this day.
They really did. They assumed that because the ultimate goal was a smaller or simplified system, the planning process could be simplified too.
Or just tossed out the window entirely.
Exactly. They showed up to the dirt lot and just started slapping bricks together.
And the source text points out the specific mechanical consequence of this behavior. This improvisation led to a simplification that actually required continuous, endless maintenance.
Let's break down why that happens. Why does improvised code demand endless maintenance?
Yeah, why is that?
Well, when you improvise a complex system, you create something incredibly fragile because you aren't documenting how the pieces connect.
Ah, right.
Imagine a developer writes a quick script to move a patient file from folder A to folder B. It works. Then someone says, oh, we also need that file copied to the billing department.
So they just bolt another script onto the first one?
Exactly. They keep doing this, adding patches and band-aids. There is no central skeleton holding it together.
It basically becomes a digital Jenga tower.
Exactly like Jenga. Eventually, one minor thing changes. Maybe the hospital updates its operating system. And because the graduates didn't map the dependencies, fixing one bug breaks 3 other things.
So they just spend all their time putting out fires they inadvertently started.
Right, and it wasn't a failure of coding skill. These were recent graduates. They knew the syntax of the programming languages. It was a complete failure of methodology.
Wow. Which brings us to the core thesis of the book, and really the reason we are diving into this specific chapter today. We aren't just doing a post-mortem on a hospital in the 90s.
No, definitely not.
The author draws a direct causal line from those improvising graduates straight to what is happening on our screens right this second.
He explicitly warns that the exact same foundational errors made by those young graduates are being committed on a global scale today with AI platforms.
To really hammer home how much technology has evolved and how our human mindset completely hasn't, Professor Piano shares this incredible detail from his own life.
I love this part.
Yeah, he talks about buying his very first computer, a Sinclair Spectrum Z80.
An absolute classic piece of computing history from the early 1980s.
Right. He bought it for 300,000 lire, and he decided to program a rally racing game on it. But he didn't use modern software with drag-and-drop interfaces.
No, of course not.
He wrote it in assembler, which is basically raw machine language. He had to manually intervene on every single memory register.
Yeah, and when you are working in assembler, you are essentially telling the physical processor, put an electrical charge in this specific transistor.
That is so wild.
It requires absolute unforgiving precision. You cannot improvise in assembler. If you skip a step, the machine simply will not run. It forces discipline upon the user.
But the text notes how, over time, languages evolved to be higher level. We went from assembler to Fortran, then COBOL, and eventually to the visual interfaces like Windows and macOS that we use today.
Right, and this evolution distanced the user from the raw circuits.
It created layers of abstraction.
Exactly. And that abstraction made computing highly accessible, which is wonderful for mass adoption. But it completely removed the forced discipline in the Z80 era.
Because the machine no longer demanded a flawless blueprint from the user just to boot up.
Right. The operating system handles all the messy details behind the scenes now.
Which brings us to the ultimate layer of abstraction large language models.
Professor Piano defines an LLM as an unstructured macro language.
Okay, let's translate that for a second. A macro language usually automates a series of tasks, right? But what does he mean by unstructured?
Well, in traditional programming, even in Python or Java, you have strict syntax. If you miss a comma, the code fails.
Right.
An LLM is unstructured because the input is natural human language. You can talk to it casually, with typos, using slang, and it will still process the request.
It is the ultimate evolution of pulling the user away from the circuits.
It really is. But because it is so advanced, and because it speaks back to us in our own natural language, people are massively underestimating the risks.
This is the LLM delusion he talks about.
Exactly. Users fall into this delusion. They wrongly assume that the AI can just do the work for us. They think they don't need to feed it correct information, or ask precise questions, or design a framework.
They are acting exactly like those young graduates at San Pio.
Exactly. They are improvising without a plan, assuming the sheer power of the AI tool compensates for their lack of human methodology.
Okay, here's where it gets really interesting. I have to push back here, though, or at least play devil's advocate.
Sure, go ahead.
Isn't the entire selling point of ChatGPT or Claude that I don't need a blueprint? I mean, if I have to spend 30 minutes writing a complex architectural constraint just to get an email drafted, haven't we completely defeated the purpose of automation? The promise was speed.
The promise is speed of execution, not speed of thought.
Oh, interesting.
Think of an LLM not as a magic wand, but as a highly talented, lightning-fast, but completely amnesiac intern.
Huh? I like that. An amnesiac intern.
Right. If you tell that intern, hey, write a marketing report, they will sprint to their desk and write one in 5 minutes. But because they have no memory of your company's values, your target audience, or your previous campaigns, they will just guess.
And when an LLM guesses, it defaults to the most generic, average synthesis of its training data.
Or worse, it hallucinates facts to fill the void.
So you get a report back, realize it's completely off-brand, and you have to spend an hour rewriting it yourself anyway.
Which puts you right back in that radiology lab with the graduates performing continuous, endless maintenance on a broken output. You thought you were saving time by skipping the blueprint, but you actually just created technical debt.
That is a brilliant way to look at it. So since we firmly established that treating AI like a mind-reading intern leads to disaster, we have to look at the author's proposed solution.
Right. How do we fix this?
He refers to this current era of technology as Transition 5.0.
For context, Industry 4.0 was all about raw automation, the Internet of Things, getting machines to talk to machines.
Right.
Transition 5.0 is the shift toward integrating that raw technological power with human-centric, sustainable, and empathetic frameworks. It's about putting the human back in the driver's seat.
And to survive this transition, he offers a very specific, mechanical antidote to our culture of improvisation.
He does.
He argues that to get concrete, useful results from an LLM, your prompts require preventative analysis and planning. He explicitly compares it to building a business model.
Because an AI project doesn't start with the algorithm, it starts with the blueprint.
Right.
And the author breaks this blueprint down into 4 non-negotiable pillars. Before you type a single prompt, you must define the context, the objective, the constraints, and the resources.
Let's make those 4 pillars incredibly concrete. So if I want our amnesiac intern, the AI, to write a financial summary, the objective, obviously the summary document itself.
Right.
And the resources are the raw Excel data files I upload for it to read.
Yes. But the magic, or rather the architecture, happens in the other 2 pillars.
The context and constraints.
Exactly. If you don't give it context explaining that this summary is for potential investors who value conservative growth over risky expansion, the AI doesn't know what tone to strike.
It's just flying blind. And if I don't give it constraints like explicitly stating, do not include any data from Q1 and ensure the document is under 2 pages, the AI will likely give me a 10-page ramble that includes irrelevant history.
Exactly. By defining the context, objectives, constraints, and resources, you are acting like the senior architects at San Pio Hospital. You are building the scaffolding before you pour the digital concrete.
Right. You are forcing the unstructured macro language to operate within a highly structured environment.
But then the author throws a fascinating curveball into this very logical, mechanical framework.
Oh yeah, this surprised me. He says the absolute core requirement for surviving Transition 5.0, the secret ingredient that makes this whole framework function safely, is a soft skill:
Empathy.
empathy. We need to tread carefully here because empathy is frequently tossed around as like a corporate buzzword.
Yeah, it usually sounds like holding hands in a boardroom.
Exactly. But Professor Piano defines it in a really rigorous, systemic way. And this draws heavily on his incredibly diverse background, which spans computer science, sociology, philosophy, and theology.
That resume allows him to see the intersection of human systems and digital systems.
Right.
He defines empathy not just as feeling someone else's pain, but as the capacity to understand the processes underlying the well-being of who or what we interact with.
The key word there is processes.
Yes, it is a systemic view of empathy. If you're building an AI for a hospital, a non-empathetic objective is simply, process patient files 20% faster.
Right, which sounds efficient, but ignores the human element.
Exactly. An empathetic objective, utilizing constraints, is process files faster without ever auto-deleting anomalous data, because an anomaly could be an undiagnosed tumor.
Wow, okay.
That is process-oriented empathy. It is anticipating the human impact of the system's architecture.
And the author brings in neuroscience to illustrate just how critical this is. He points out that a human brain forms its algorithms, its core ways of processing the world, handling stress, understanding relationships, based on its environment during the first 7 years of life.
The context of childhood physically wires the brain.
Right.
If we connect this to the bigger picture, if that early context is empathetic, if it understands and supports the child's well-being, the resulting neurological algorithms are generally resilient and healthy.
And Professor Piano argues that AI development is mirroring this biological reality. AI needs a properly defined, empathetic context to be safe and effective.
Exactly. Empathy isn't about making the AI have feelings. It's about the human operator defining the AI's context with a deep, structural understanding of the well-being of the people the AI will ultimately impact.
Right. AI is a decision support tool.
Yes. It is meant to help humans navigate complexities, much like a complex radar system helps a pilot navigate a ship through a storm. It is not meant to replace the pilot's foresight or human ethics.
It's the difference between building a tool that amplifies our capabilities and building a tool that bulldozes our workflows because we couldn't be bothered to give it a proper set of constraints.
Which brings us full circle to the danger of the improvising graduates. When you just improvise with AI, you are stripping away the empathy.
You're ignoring the context.
You are ignoring the context and the constraints out of desire for instant gratification. You are demanding an output without considering the systemic impact.
The SanPio project succeeded because the architects understood the exact high-stakes context of a radiology department. The graduates failed because they ignored that context in favor of moving fast and breaking things.
Right. We have transitioned from the painstakingly precise Z80 processor to the vast, unstructured world of large language models, but the human trap remains entirely unchanged.
Technology evolves exponentially. Human methodology, unfortunately, requires constant, deliberate effort to maintain. We've covered a lot of ground today. From the triumph of the meticulously planned voice reporting system in the 90s to the fallout of the young graduates who thought they could skip the blueprint, and finally to how that exact dynamic dictates whether your current interactions with AI will save you time or drown you in continuous maintenance. So what does this all mean for you?
Well, the author leaves us with a truly profound concept. Because human algorithms are shaped by their early environment, he asserts that all parents are AI programmers.
Or biological intelligence programmers. Right?
Exactly. They set the initial context, they define the framework.
That is a staggering responsibility.
It is, and it invites a terrifying yet necessary thought experiment.
Okay, I'm listening.
If the humans using AI today are acting as the parents, defining the context for these models, what happens tomorrow?
Oh, wow.
We are rapidly approaching a point where AI agents will be tasked with writing the code and setting the parameters for the next generation of AI models.
So compounds.
The compounds.
Yeah.
If we don't rigidly embed process-oriented empathy into the constraints right now, we aren't just improvising a bad tool for today. We might be hardwiring a permanent, inherited architectural flaw into the digital ecosystem of the future.
That is chilling, but so true. So when you sit down at your keyboard today, are you laying a solid foundation or are you just playing in the dirt?